Hello, thank you for attending this section. My name is Jaeju, a master student in Sungkyunkwan University, Korea. This work is conducted with Bosung, Jeongho Kim, Geonwoo Park, and Simon Wu. I will present our discussion paper exploring racial bias in classifiers for face recognition. For introducing our discussion, I'm going to talk about bias in machine learning system. An imaging classification model trained with only good quality zero imaging, it cannot classify the low quality of zero image. And also, a landmark extraction model trained with only left-sided women image cannot detect landmarks in the right-sided man image. This is because of that the training and test distributions are different. Thus, for making general machine learning model, we need to consider some factors for building balanced dataset. In this work, we focus on these bias on face-related applications. For face applications, they are developed for many critical areas, such as user authentication, human identification in crime database, or recently checking system for mask and temperature. In all of them, if the models are trained with unbalanced dataset, both false positives and negatives lead to serious issues by making wrong decisions in real-world usage. Hence, the training dataset must contain diverse samples with reasonably balanced ratio. However, we notice that the common facial dataset has critical problems in terms of racial balance. The problems are as follows. First, most of datasets focused on balancing skin color and age. Second, the common datasets usually used for face recognition, labeled faces in the wild, LFW, or deep learning face attributes in the wild, CELB-A, are unbalanced, which is 80% of the samples are white people, and only a small portion of it is black people or others. Third, there are no research for racial bias between Western and Asian, which indicates a lack of consideration for Asians. So we plan to extend the previous work by exploring data fairness regarding different races, Western and Asian. Our motivation is as follows. It is the first attempt to consider the racial bias between Asian and Western. Second, we need to explore biased result in lack of ethnicity in real-world usage. Finally, we alarm the lack of diverse ethnicities of face dataset is critical problem. So it is our overall procedure. The component is building dataset, a training model, and evaluating the model. For building dataset, we collected celebrated images from the internet and crop the face region with MTCN method and manually select the good quality images. So the result would be the balanced dataset, which has the two authentities, Western and Asian. Then we build a gender classifier model and train the model with only one ethnicity of Western or Asian. So the model is optimized with traditional cross-entropy loss. So next, we evaluate our classifier with the other ethnicity. So the model should produce the correct label. The image is women or men based on the biased dataset. Plus, we conduct same experiment with ImageNet pre-trained backbone network for same scenario. Here is the detail of our experimental setting. We will have total 1,190 images. For Western, there are 595 images and 268 representing men and 327 representing women. And the same proportion holds for Asian people. For classification model, we used exception and mobile network tool. Since the former has shown to perform well on face recognition tasks, and the latter has a lightweight use case for many practical face recognition tasks. For transfer learning, we use ImageNet pre-trained weights, and the setting is you can see in the slide. This is our preliminary result. In exception, and see Western here means the classifier trained with the training samples on a Western dataset, and C Asian is vice versa. D Western means the test samples of the Western dataset, and D Asian is vice versa. And case A is the setting training model from scratch, and case B is the setting training model from ImageNet pre-trained weights. So in exception, Western classifier produces 3% higher accuracy in Western test samples than Asian, and Asian classifier produces 23% higher accuracy in Asian samples. You can observe the same trend in MobileNet V2 model. So it is interesting that training only Asian images induced more biased results. We think that this result is due to the fact that Asian has more biased features than Western people. In case B, exception, based on exception, Western classifier produces 3% higher accuracy in Western dataset, and Asian classifier produces 10% higher accuracy in the Asian. And you can see that almost the same observation in MobileNet V2. So training Western classifier based on ImageNet pre-trained weights showed more biased results. However, for training for Asian classifier showed less biased results. We interpret this observation as for ImageNet pre-trained weights, there are the weights is already familiar to Western people because of in ImageNet there are some labels like cowboy or women and hat wear on Western people. So the Asian classifier can resolve some of the biased results training Western formula weights and West Asian dataset. However, for Western classifier is getting more biased training Western dataset based on already familiar Western weights. This is salience map for visualization for based on exception model. The salience map is calculated by the vanilla backpropagation method. Western classifier, C Asian, using exception, produces proper salience map, as you can see in the left figure. The model produces eyes or leaves and facial edges for both of Asian images. However, for Western images, it just produces random points, which means it cannot use any other information of the images. And C Western, using exception, produces proper salience map for Western images. However, it produces random points of Asian images. As you can see in green rectangle, unmatched case for C Western, like Western classifier meets the Asian images, extracts more distinguishable features than opposite case of C Asian. We interpret this observation as Western people have more trainable face features like more big eyes or clear eyes and nose or no forehead, etc. There could be many other reasons, but I don't dig in this session. So we verified that there are clear racial bias between Asian and Western. Here, We discuss some issues when deploying the biased model and solutions briefly. There are two issues when deploying the biased model. First, biased model gives unsatisfactory user experience by classifying people into different labels, not human being or etc., which is very critical issues in user-friendly AI services, and it could be recognized as racism. Second, face-related bias results are directly connected to security issues by the vulnerability used as backdoor in some cases. For example, let's say there is a user authentication system and the model is trained with only short hair administrators. And the model can be easily fooled by the short hair images, which is not the administrator. So we pick the security issues. For solution, we suggest that when making dataset, we should ensure that it should include diverse ethnicities when building face-related service applications. And second, for that, in addition to that, focus on building robust classifiers in the presence of imbalance is important. For that, there are a research area called domain adaptation or generalization, which is quite interesting method to solve this problem effectively. So for conclusion, we performed experiments to explore the effect of racial bias with simple gender classification problems. And we demonstrated the variance in accuracy. The highest is 23% on the data composition in preliminary results. And we alerted that the balanced facial data set is of paramount importance for real-world applications. And it is my end of presentation. And thank you for listening.